Here board module, individual LED are used with distinct roles. The red LED indicates the player 1 position, the blue LED shows player 2 position, the green LEDs marks both bottom and top of a ladder, and the yellow LED shows snake's head and tail position. The board has total 16 blocks. Each block contains 4 LED that represents full game information. All LED shares all LEDs shares a common power supply. All LEDs anode shares a common power supply as since the LED are designed as active law components. On a 4-bit binary, binary number is applied to the LED board. The corresponding LED matching is equivalent and then LED lights up. Additionally, is to the decision to use a common anode for power supply helps reduces the number of ICs needed. This is because a widely available active load decoder outputs 0 instead of 1. This is an active load decoder which gives output 0 instead of 1. Because of this, we have to use extra NOT gate for all LEDs. This requires extra number of ICs, which is not an optimized version for our PCB. So we have to use this anode as common power supply to overcome this problem. Finally, all LED connections are combined to form the complete configuration. Thank you. This is the snake ladder logic module subcircuit. In this module, there we use ladder, mux, comparator, and demux. This is the complete 4 input, 8 output demux. How did this demux works? This is the selection button between player 1 and player 2. When first of all we come to this ladder. This adder adds player position and dice value to this adder, and output of this adder are sum of player position and dice position. This output will be this output gone to this marks, and this marks operates on selection button come. This selection button is the input output of this ladder carry. Why this marks is used? Because the when player position and dice value sum value is above 15, then it gives some carry. This carry, that means this carry will works as a selection button. On this it gives some carry, then it select B. What is the B? B is the current player position. Then it passes the current player position when the player position and dice value is above 15. So this marks is for that purpose. And then the ladder comparator compare between ladder bottom position and player position. When these positions are matched, then A is equal to B gives output 1. This output 1 enables this AND gate. This AND gate passes ladder length and added to the current player position. This ladder output also go to this multiplexer. Why this multiplexer? When the length is and current position added, and when it goes to above 15, then it cancel out the ladder length and remain the player position as initial one. So this max is used for that purpose. After this max output, it will go to snake comparator and this snake subcircuit. Why this? Because we prioritize first ladder position, then snake will come. When in one position, snake and ladder both will come, then we prioritize ladder position. So this, because of this, first of all ladder function works, then it goes to output. The snake will not work as we prioritize this ladder position. For snake position, snake comparator compares between snake head and player current position. If this matched, then this AND gate will enabled and passes the snake length. This snake length subtracted to the current player position, and because of this output of the snake subtractor will go to these marks. Why these marks? It also when this subtracted value is less than 0 or below 0, then it cancel out the ladder length and remain the player in initial player position as intact. Then this multiplexer outputs go to this demultiplexer. However, this is the selection button between player 1 and player 2. When 0 is come, then player 1 activated. When 1 is come, then player 2 activate. This is the working procedure. Now I run this circuit and show the above circuit. For this is declared a logic circuit. This circuit is a special feature of dice value 1. This working principle of this circuit is on compare between player position and 0. When player position is equal to 0, then it passes A is equal to B1 and A is greater than B is equal to 0. When player position is 0, then it passes 1 and gate will all activate. And when player position is 1, this and gate will also passes 1. Then ultimately this 2 input 1 1 output will also 1. Then output for 1 the marks selection B. Select B. What is the value of B? B is the dice value. So dice value will also passes to this marks 2. When dice value is 3 and player position is 0, then it passes 0. Why? Because 3 it deactivate this AND gate and comparator is equal to B is not equal to 0. Then it will also give output 0. For selection button 0, it gives output A. A is equal to what? Grounded or like grounded, like 0. So output will remain past 0 as it is 0. And it will also come to, then it will also work as same as 3. It will work when dice value is 1 and dice value is 1. This circuit is completely a special feature of this dice value 1. At initial position is 0. When player position is 2 or have some value of player position, then this circuit will not works properly. Like will not works. When player position have some value, then dice value is 1, it passes 1. When dice value 3, it passes 3. When dice value 2, it also passes 2. So when player position have some value, this circuit will not works. So when player position is 0, then it will works for when dice value is 1, then it works properly. This is the special feature I have discussed in this logic module. Then finally we see this circuit is how the circuit works. So now this IC is adder. So first of all we keep player position 2 and dice value is 1. So 2 and 1 is output gonna be 3. So this is the selection button of these demarks. Each selection between player 1 and player 2. When 0 comes, then player 1 activated, and when 1 comes, then player 2 activated. So this adder also works properly. After this adder output goes to this marks. Why will you use these marks? Because when player position is like 14 and dice value is 3. 14 is and 3 is equal to what? 17. So 17 is above 15. Above 15. So it passes some carry. This carry works as a selection button of these marks. So it passes B value. What is the B value? B value is the initial player position. So it passes 14. Here is the output of this 14. See, 17 will not passes. Why? Because of these marks. So these marks will also works perfectly. After then, we use this ladder bottom position. We keep this player position to 2 and 3. Dice value is 3. Then 2 and 3 is equal to 5. This is 5. And we keep this ladder bottom position also 5. Then this ladder length will also keep 5. Then 5 plus 5 is equal to 10. See, this output is equal to 10. So ladder also works perfectly. There have some invalid case also. Ladder position is when above 15, then it will not passes. Like on 5 and like 10. This is 14. 5 plus 14. It it will remain same. So this carrier will passes 1. Because of this one, it will remain the same as player position. So this is the invalid case. And next we got to snake comparator. First we priority this ladder, then snake. When two ladder bottom and snake head are gonna be same position, then the priority will ladder. When ladder is something, then it works properly, but not for snake because as we priority this ladder. Then after we works how this snake computer works. Like we given this as 8, 10. 10 plus 3 is equal to 13. See, this is 13 and we place snake head to 13. Here is 13 and snake length to 13. Then it will remain 0. See, it will remain 0 value. Then it will remain 0. When snake length is like 3, 3 minus 13 minus 3, it will gonna 10. See, snake position will also works perfectly. These are the complete overview of the snake ladder logic module. Thank you.